Okay, this question is about complex numbers and the roots of complex polynomials. So, we are told that the roots of an equation, this equation z cubed subtract 8z squared plus 22z subtract 20 is 0, are z1, z2 and z3. We're given z1 is 3 plus I, and we're asked if we can find out z2 and z3. First thing to note for your easy mark, 1 mark, that z is 3 subtract I must be a root, be a root, and the reason is roots occur in complex conjugate pairs. Complex conjugate pairs. Okay, so that's your easy 1 mark there. Next thing, you are told that z is 3 plus I is a root. Okay, so subtracting 3 and subtracting I from this tells you that z subtract 3 subtract I must be a factor. Right? And you also know, you've just stated that z equals 3 subtract I is a root, so therefore z subtract 3 plus I is a factor. So we have 2 factors now of this polynomial. We can multiply them together. So let's multiply the factor z subtract 3 subtract I by z subtract 3 plus I. Let's do it very carefully. The way we're going to do it is we're going to do z multiplied by everything here, write it on the top line, then negative 3 multiplied everything here, write on the second line, etc. So z multiplied by z is z squared. Z multiplied by negative 3 is negative 3z, and z multiplied by I is plus iz. I'm going to get a different coloured pen there. Now I'm going to do this one. Negative 3 times z, I'm going to write it in the z column, is negative 3z. Negative 3 times negative 3 is plus 9. I'm going to write it over here by itself. It doesn't have a column yet. Negative 3 times I is negative 3i, so I'm going to write it in its own column. There's no just purely imaginary parts at the moment. Okay, and the last one, therefore, I'm going to do in black here. Negative I times z is negative iz. I'm going to write it in this column. Negative I times negative 3 is plus 3i. And negative I times I is negative I squared. And negative I squared, if I squared is negative 1, negative I squared must be 1. So I'm going to write it in that column. I'm going to put a line under them. And I'm going to notice a lot of stuff cancels. Plus iz, subtract iz. Negative 3i plus 3i. 9 and 1 is 10. Negative 3z is negative 6z. And z squared on its own there. So therefore, I know that z squared subtract 6z plus 10 is a factor, and I can use this to help me get the third factor, because I'm going to write this down. I'm going to write z cubed subtract 8z squared plus 22z subtract 20. It must be equal to this factor multiplied by the other factor, so it must be z squared minus 6z plus 10, right, multiplied by another factor. Now we can work that factor out. What needs to go here to multiply by z squared to get you z cubed? Well, z obviously, and that gets you the z cubed you're after, because that times that is z cubed. But it also creates for you a negative 6z squared. I want negative 8z squared, right? So I need a negative 2 here, because negative 2 times that will give me the extra negative 2z squared I'm after, and I will have negative 8 squared. And I'll be done here and here. It also gives me plus 12z from that times that. Okay, and it also gives me plus 10z from that times that. So these two give me the 22z I'm after, and negative 2 times 10 also gives me the negative 20, so I'm done. So therefore, the other root must be positive 2. So just to get your final mark, to state that the root z1 is, we're saying 3 plus I, z2 is 3 subtract I, and z3 must be 2. Okay, now I'm just going to rub this out and draw these on the Argand diagram quickly. I'm going to rub all that out here and just keep in my let's just quickly draw an Argand diagram. This is the easiest part of it all. I'm going to draw the complex number 3 plus I, so it's 3 across, 1 up, so it looks something like that. Make sure you label it 3 plus I. 3 across, 1 down, 3 minus I is 3 subtract I, and Z3 was equal to 2, we said, so that's simply 2 across, it's here. Simple as that, and you get yourself your extra 2 marks and you're done.